Hi, Mr. Corsi here. In this question we've got a cubicle storage cupboard. Chris is an umbrella 85 centimetres long. Unfortunately the storage cupboard's only 70 centimetres high. He's wondering whether it'll fit from P to M. Justify your answer. Now if I was Chris I'd just open the cupboard and try it. However, we've got to do calculations that will convince the examiner that his umbrella either does or does not fit into this cupboard. So this drawing then, three-dimensional drawing, is on a flat piece of paper. The hidden lines are dotted. Some people find it very difficult to get a sense for the three-dimensional nature of this drawing. So let's first of all look at this drawing and explore it from the three-dimensional point of view to get a feel for what's going on. So here we have a drawing very similar to the one in this question, but in this one I can rotate the solid that it represents. And you get a good feeling for the three-dimensional nature of that drawing. Let's have a look now at the line that we're trying to calculate. It's from the back top corner to the front bottom corner. So that's the line that we're trying to calculate. And you'll notice that that line is not in any right-angled triangle in this diagram. There's no right-angled triangles that has that as its hypotenuse or side. What we can do though is draw in another line, this line in the bottom face, and once we do that we then do get right-angled triangles appearing. Now the line we're trying to calculate from there down to there is the hypotenuse of that white triangle. So this is the line that we're trying to find. We know the height of this container, we know this side, but we don't as yet know this side's length. However, this side here is the hypotenuse of another right-angled triangle where we know both of these sides, as the base is a square, and we do know the lengths of these sides. If we look down on that we can see this white right-angled triangle. There's the square base, and we do know these two lengths, and therefore we could work out this third hypotenuse side. So that's the picture, and now you maybe have a feeling for the three-dimensional nature of it and where right-angled triangles are coming from. So let's go back to the question. So here's the cuboid we're dealing with. Here's the space diagonal. And here's that other line that I drew in. There's the right angle, and there is another right angle. And hopefully you can see that now that I've shown you the three-dimensional nature of that drawing. Let's name the points. That's P, that's M. Let's call this N, and let's call this O. Let's put in values. This side is 40, this side is 40, and we know the height is 70. So the stages that we'll use, we'll first of all take the flat triangle on the base. So that's triangle OMN. And triangle OMN, we know MN squared will be equal to OM squared plus ON squared. That's a 40 squared plus a 40 squared will give you the hypotenuse squared. So 40 squared plus 40 squared gives the hypotenuse squared. So that's a couple of 40 squared. Now you'll work that out in the calculator. That'd be 1600 plus 1600, that's 3200. And therefore MN Well, do we need to work out what MN is? No, because if we're using Pythagoras in this larger triangle, the vertical triangle, we'll need to be squaring MN, which we've now got. It's 3,200. So let's go straight to triangle MNP. So we didn't need that. In triangle MNP, the hypotenuse PM squared, and that's what we're trying to find, PM. PM squared is MN squared plus NP squared. Now we do know what MN squared is. It's 3,200. And NP squared will be 70 squared. So again, your calculator, say 3,200 plus 4,900. So that'll give us 8,100. And therefore PM will be equal to the square root of 8,100. Now I do know that 8,100 is factors 81 and 100. So I could square root each of these. Square root of 81 is 9. Square root of 100 is 10. So that gives me an answer of 1090. And the question says, justify your answer. We've got all these calculations there. The umbrella is 85 centimetres. Can it fit from corner P to corner P? Yes. It can fit. Since PM is 90 centimetres, which is greater than 85 centimetres, the umbrella length. So there we go, full justification, all the calculations are there. So that's Mr. Corsi signing out, and thanks for watching this video.